Good morning to all of you. Miguel for inviting me to Chile. It's my first time here in Latin America, and I'm really enjoying seeing the mountains. So I'm a professor from the National Institute of Education, which is the part of the Nanyang Technological University, Singapore. So this is you are engineer. Most of you have an engineering background. So I'd like to use this opportunity to share with you different approaches to research, which is the learning sciences perspective. So, I've talked to some of you, Miguel's PhD students. They are doing good educational technology projects. So, I just want you to rise up more above to have broader global views of how we can do research in education. So, how many of you have been to Singapore? Oh, yeah. Quite a few. So maybe you don't know where Singapore is. It's a very, very small place. It's Chile is here. And this is Asia, you know, China, you know, and I think this is a hot spot for danger now, right? North Korea. And so this is Southeast Asia, and that's Singapore. So Singapore is a small city-state with a population of 5 million people. We gained independence from the British in 1959, so we are a very relatively young nation. So internationally, Singapore is somewhat known for its education system. So we have many visitors from other countries, like United States, countries of Europe, that come to Singapore to hear about our best practices. What you don't actually know is, actually Singapore also go to many places in the world to learn about the best practices there. So whenever we have a new policy in government or in education, or a new policy for schools, actually you go to have, there are study trips, official trips to other countries to find out what works there, and then we come back and then we adapt those lessons and use it for our own context. So in those international comparison tests like TIMSS and PISA, Singapore performed well in TIMSS in mathematics and science. So some pictures of Singapore. It's a modern city-state, lots of skyscrapers. So this is the financial district. I don't know whether Miguel is in there. This is a night view of Singapore. So this is the new part, and some of it is the old part with British colonial style buildings. And this is a symbol of Singapore. It is a Merlion, so it's a lion with a fish body. So back to business. So this is my outline of the talk. I want to share with you a learning sciences perspective to doing research. And why do we want to have this perspective? What does it buy us? And in the kind of work we do, we want our research not just to publish papers, we also want our research to have impact. So therefore, we believe the learning sciences perspective is a good approach to help us. And if there's time, I'd like to share one story of research that I am involved in. So it's actually one, it's not two stories. Okay, so in my institute, we set up a learning sciences lab, a research lab in 2005. So MOE stands for Ministry of Education. So we have funding from the Ministry of Education in this learning sciences lab to do research on deep student learning with technology-enabled pedagogical practices for cultivating 21st century knowledge and skills through learning sciences research in Singapore schools. So this is our mission. So we do technology work such as immersive environments for doing science inquiry. We put students into Second Life to do argumentation. And then we also introduce mobile learning devices, mobile devices for students to learn. So just to boast some figures. So the lab from 2005 to 2011, we have so far 84 research projects. And the total funding is about US 16 million. So altogether we've engaged 85 over schools in Singapore. So in Singapore there are 360 schools. And then we work with 500 plus teachers and 10,000 students. So we have a research lab and we do school-based research. And the research methodology we use is learning sciences. So I want to share a bit more about what learning sciences approach is. Okay, so the next few slides are worked out by my colleagues, Long Xiang, which Miguel knows, and Ming Hong. Okay, so as you know, there are different perspectives to learning, different paradigms. So in the early days, you have behaviorism, right? And then in the 60s, you have a cognitive view, cognitivism, and then you have views from constructivism. Okay, so it's a picture of 3 students in Singapore. Okay. So behaviorism, the brain, the mind is a black box. So we don't know what's inside, but we know you provide the inputs, we know the outputs. So that's behaviorism, and as you know, in the early years, 50s, 60s, a lot of the work is influenced by behaviorism. So what we are saying is actually the schools, the way they are run, is in fact very much based on behaviorism kind of thinking. Even the schools these days, because they teach a lot of content to students. And then we have the cognitive views on learning. So it's no longer a black box. So we imagine what's the mental models, imagine what happens in the brain of the student. So we look at mental processes such as memory, mental structures, proud knowledge, misconceptions. Imagine the brain might be like a computer, how it processes information, how it remembers information. And then there's a view of constructivism. So it's no longer looking at the head by itself, but the environment where the head is. So it's a social cultural perspective. So for what we do is we make meaning a lot from the experiences with the world. And from this making meaning experiences, we learn. So it's not just looking at the head, the mind, the individual as a unit of analysis. You broaden it to look at the context. So look at things like identity, social relationship, classroom culture. So these are different views. Okay, so therefore you have these different research paradigms. You have educational psychology, you have instructional design, and then you have educational technology. So and then there's learning sciences. So I put this table to help you contrast different paradigms, different research methodologies in this field. Okay, educational psychology. What's the objective? Objective is to understand learning, and very much the perspective is based on what I just described. Early days with behaviorism, cognitivism, and now some of the more progressive views move on to social constructivism. And the research methodology is mostly informed by psychology, and some of the recent researchers have moved on to methods from anthropology, linguistics, looking at discourse analysis. And then the objective is understand learning. So they are not so worried about creating design or creating intervention in the school. Okay. Then your instructional design. You know, you have schools of instructional design. You go to take a degree to be an instructional designer. And what's the objective? To create good instruction, for example, by following the ADDIE model, ADDIE model. And the objective is to improve learning. Okay. And so what do they do? They do design and intervention, and they test it in control settings. You know, that means you bring students to a lab, and there's an experimental group, and then there might be a control group. So that's basically their paradigm. And then educational technology, very much similar. You know, you design environments which use technology, and the objective is also to improve learning. And a lot of the work is also done in control settings. Okay. So these are the main disciplines in this field of learning. And then we have the learning sciences perspective. It's not a very developed field yet. I mean, it's not a developed field yet. It's developing. And we have the field because it's trying to address some of the weaknesses of these earlier paradigms. So the objective is look at it from the perspective of not just learning, but the learning ecology. So take a broader perspective of, learning happens in ecology. And the objective is to, understand how the ecology works so that you have better chance of influencing it. And you also use methods from these earlier fields. It's interdisciplinary. For example, use methods from psychology, anthropology. You do case studies, qualitative research. So use all those methods. So one characteristic is for doing design intervention, it doesn't do it in a lab. You go out to the real world environment of schools, or go to a home where students learn informally and study them in natural settings. So the sense is you have better handle on the realities of the ecology in which learners learn. And to do that, the methodology is design-based research. So I'm going to say more about design-based research. So this table gives you a sense of the learning sciences field. So as I said, the focus analysis, the mind is what behaviorism and cognitive science look at. And then we think that's not sufficient, it's not a complete view, so you have to look at the mind in the classroom, and even broader than that, mind in the society, to look at a broader view of learning in a social cultural perspective. So it's not just looking at how technology or pedagogy work. You must also look at the classroom culture. You must look at the power structure relationships. You must look at other aspects, of the ecology. So we had this discussion, Miguel, and said that the Singapore mathematics curriculum is an approach that might help address all the problems. And he's right in saying that it's not just the approach. There's a social culture part of it, which is the value that Singapore students place to education, which makes it work. So it's looking at it from a richer point of view, considering the ecology of its use. Okay, so that's the introduction of learning sciences. So just want to point out some broad trends in research. From what we know of, we look at learning sciences, and it's the interplay between the individual and social cultural aspects of learning and the organizational aspects of learning. So a lot of work ended as research. It doesn't go out to practice in the schools. That's because we do not worry about the organizational aspects of learning. So those are important aspects of which you need to look into. So the relationships between individual and social cultural aspects. So the individual part will be the mental processes, the representations, and the notion of conceptual change. What makes a student have this aha moment, when you change your fundamental beliefs. So those are very much an individual perspective. And you also need to look at things, this still also look more broadly at inquiry-based learning, higher order thinking, and self-regulated learning. So the mental processes and the practice-informed concepts. And then there's a social cultural perspective, and these are also important issues. So identity, discourse, new literacies. So identity, our learners, the youth is very savvy in technology. They have different identities. Immerse them in Second Life or immersive environments so they can experience different identities in a social cultural context. And then practice-related concepts like computer-supported collaborative learning and knowledge building. So it's important to consider not just individual but the social cultural aspects of learning. And on the organizational aspects, so to try to do research and try to address problems of school, you have to look beyond. You also have to look at how to help teachers to develop, how to help teachers to learn. And Miguel does it under the word orchestration. A host of issues how to help teachers to really use technology to manage classroom well with a host of resources, paper, digital, and other resources. So technology enhanced learning. And some newer aspects of work, which is not just learning in the school, but learning outside of school. How learning crosses these boundaries, between school learning, out of school learning, between digital learning and non-digital learning, between individual learning and social learning. And the issue of translation and scale, which is very important for us because it invests a lot on those educational research projects. So it works in one school, how do you translate, how do you apply it to other schools with different conditions? So that's issue of translation and scaling up. So I was head of the Learning Sciences Lab for the first few years, but now I started a center to look into these issues of scaling and translation. Because the Ministry of Education has funded us for 2005 to 2011. So how they start to ask questions on the return of investment. So how has this research benefited schools? Therefore, you need to look into the notions of how to do translation and scaling up. Okay. I think I'll skip this slide. I want to get into design-based research. Okay. So the approach in learning sciences is design-based research. There's a couple of slides to elaborate on this. So just want to say that learning sciences is a growing field. There are more undergrad and grad programs now that specialize in learning sciences. Okay. So I want to motivate the problem again. You take a look at this quote which was made in the year 2001 by two Americans, Nora Salabelli from SRI and Chris Edie from Harvard. So there's a lot of research out there, but by and large, there's a gap between research and practice. So I think this is acknowledged in the educational research community. There's a big gap between educational research and practice. So where the learning sciences folks come from is it tries to have a better handle on this problem. It thinks about what kind of research is needed. So therefore, a learning sciences research to understand how students learn. So it's about understanding how do we learn. So you might have a design intervention, and then you do a study that shows that it works. Compared to another group or class or students who do not have the intervention. But that's only the empirical result. You need to unpack further to explain what's the main effect of the intervention. How do students learn from the approach? So to do that, we go to the real world environment, school-based research, school-based design-based research, to create what you call pointable models. So you look at it, you see that there's a model out there, and this is how you work. You create the models in the school. You don't create the models in the lab. I want to emphasize that again. The model is created, the design is created in the context of the school by researchers working in schools to create these interventions. And this is an approach that learning sciences researchers believe can lead to more sustainability and scalability. And by working with teachers, you build capacity in teachers to do this kind of research. So design-based research is iterative and is collaborative. Okay, so you have cycles. First you design, and then you develop, you implement, you evaluate, you collect data, evaluate, and then you go through this. So the thinking is you want to design a solution to help schools, but you cannot design it in one step. You cannot design it in the lab. You must go out there to the community, to the user base, to the school, and iteratively develop this design. And you don't do it by yourself, you do it with the stakeholders. So these are your teachers, that you work with. And it's a process of design. It's a process of design. But it's not just trying to solve a problem by itself. This is also academic. In the process of doing this, you must develop theory, or you must also refine theory. So this makes it closer to a scientific discipline. It's not just trying to solve a practical problem in the school. So maybe you don't need researchers to do that. But researchers must use theory, design principles to build the design. And through this design, iteratively, as you try out, you come back to improve the design principles. So it becomes better and better. So where does experimental control testing comes in? It comes in later, after you have developed the intervention, the solution. It cannot be right at the beginning. So a lot of research, they do this in the lab, and they will try to transfer out to the school, but it doesn't work. So design-based research, you develop this intervention, a few cycles, then you do the experimental control testing. Okay, so I have some information. The PowerPoint is still available to you, so I think I won't go through this. So someone asked me, so what's the difference between design research and action research? So action research is what teachers do. Teachers do their own research to improve their own classroom practice. So what's different? How is design research different from action research or experimental research? So here's a table to give you a view of that. Take a look at it. So action research, who does it is teachers. Design research is researchers, and experimental research is also researchers. So experimental research, you test hypothesis, right? One condition compare other conditions. Usually, you have to control all the variables, right? And then, therefore, it's unit variate analysis. You know, you want to only vary one variable. But reality is, in the real world, in the schools, it's very difficult to control the variables, right? You know, you go out to schools, you know, it's very difficult to control variables. So design research look at multivariate, action research multivariate. Experimental research is done in the lab. You know, all this is done in the classroom. And the teacher's role, you know, you bring it to a university or lab, so it's typically limited teacher involvement. In fact, even the researchers take over and do it, right? I think your teachers go and teach it directly. So that's why you have experimental research. But action research, design research, you let the teachers do it. And researchers can still play a role as a supporting role in the classroom. And the teacher is a full conductors in action research. And theoretical foundation, of course, is very strong in experimental design research, but it's weak in action research. Action research is just practitioners, teacher practitioners, doing things to improve their own classroom practice. And the purpose, so experimental research, you want to generalize the findings. You know, you prove the hypothesis, you generalize it, and you stop there. So you don't, so I think that's where the problem is. Nobody will take the finding and try to generalize it to a host of other contexts. Design research, the sense is, because you go to the messy world of the classroom, you have a better sense of understanding the real issues there to find a solution. So you reflect a lot on, you know, the outputs of research, and same for action research. Okay. So there's a general part. Basically, you're all researchers, me too. I just brought you many thousand feet up and looked down at how people do research. Miguel brought me to 3,000 over feet to the mountains. So maybe I'm not so high, but at least we rise above to see, you know, the different research methods in the different disciplines. Okay. So we have a research lab, the learning sciences lab, that do this kind of research. So my next part of the talk is to talk about one research effort that uses a design-based research approach. And this is the project that I'm personally involved with. It's on collaborative learning. Miguel has heard this story many times, but let me share that with you. So Singapore classrooms, we have a class, typically 40 students to one teacher. So we have a problem of, you know, a lot of teacher talk. So how do we have democratized participation? More students participate, be engaged, involved in thinking in the classroom. So we explore this issue, and in the past 5 years, we have been working in classrooms to introduce computer-supported collaborative learning. So through this research, we hope to understand, you know, systemic factors of how to introduce technology to the classroom, and to have design principles for introducing what we call rapid collaborative learning in the classroom. So rapid means it's in the dynamic atmosphere of the classroom. You know, the teacher asks a question, you stand up, you have to provide a response on the spot dynamically. It's not like, you know, it's not like e-learning where you're at home and you have time to think of a response. So in the dynamic atmosphere of the classroom, how do you support rapid collaborative learning? And how do we develop technologies? So these are some pictures of students doing this collaborative work. So it's a group of 5 students. I think this student is presenting the work. This is a group presenting to the whole class. So a class of 40 students, each group has 4 to 5 students. So it's group work, and then there's a classroom presentations. Each student has a device, and they also do experimental work together with the digital work. So this technology, GroupScribbles, is from Stanford Research Institute. So we work with them. We took their version 1.0, but it's very unstable, a lot of bugs. So we work with them to develop GroupScribbles version 2.0, and now it's version 3.0. So there's an iterative development of the technology. So every student has a device, 2 screens. This is your private screen. This is the group screen, the public screen. So idea is the teacher asks a question, and then you can scribble on this note. So this is like your sticky note, the 3M sticky note. You scribble your idea, and when you're ready, you tear it out and you put it on this space. Okay. So the advantage is nobody knows who contribute this. So in our context, our students is a bit shy. Sometimes they don't want to be seen as offering a stupid answer. So anonymity helps a lot by encouraging them to contribute. So once you post that, you can do a lot of things on it. You can reorganize it, you can sort it out. You can cluster it. So this lesson on fractions. So students asked to think of the different representation of the fractions. So ask, I have a fraction 1/4. Each of you draw a representation, and then you put it out there. So that's the first activity. The second activity is, I ask you as a group, as a community, to try to sort this out. You can do a number of things. You can ask the whole class to sort this out in increasing order. So that's one thing you can do. And from this different representation, to sort out to cluster this into different types of representations. So that's mathematics. Then think of a high school physics. You have a container and there are 3 holes. And the water comes out. So the teacher asks a question, how does the water come out? And then the student will draw and try to explain why it come out that way. Will it be like this or like this? Do you have any, what do you think? Which one is it? This one or this one? Do you have any, anyone good in physics here? So we don't know, right? So all of us post the ideas and explanation. And then you have a little note, peer comments, This is a peer comment. Got minus, I think. So everyone get excited. My peers think that is the way, and I think this is the way. So we generate a lot of discussion. This is an activity on learning Chinese language. So this is learning vocabulary. They read a passage, and then the difficult words, this is the difficult words. They pick it up. And then from this difficult word, they have this organizer. So there are words that sound exactly like this word. What do you call it? Homonyms, right? And then you make short phrases with this word. And then you try to explain the meaning of the word. There are different aspects of this new vocabulary. So you compare them with words that sound similar, try to make phrases out of it, and then you try to compose sentences that use this new vocab. So let me show you a video of this work. So this is a project that we do a design-based research approach. So we work with teachers to design these lessons. We do a lot of classroom observations, iteratively working out with the teachers. So theory is every idea can be improved. Every contribution is an idea can be improved. It's a lesson in science, so you draw parts, dissect, sketching the dissected flower. It's a Chinese language activity. So this is a big picture composition. Given a picture, is supposed to write a composition. This is compare and contrast. This is a teacher. So when we start, we had one or two classes that uses this pedagogy, GS pedagogy, and the other classes taught the traditional way. So we compare the performance on the traditional science assessment. So we are encouraged because the experimental classes, they did better in the assessment, and in particular, they excel in the open-ended questions. So one thing we noticed that it helps students to be more expressive, to be able to articulate and express their ideas. So we see some kind of spillover effect. It also helps them to be, to be better in the language abilities, because it needs them to vocalize or it needs them to represent what they think or say, and give them more opportunities to do so. So there's some evidence that they gain in collaborative learning skills. So through our classroom observations, they're actively participating in the collaborative learning, more effective group work, and better communication skills. And then we also do some surveys on their attitudes to science learning and towards working in a team. And those improve after 1 year. After 1 year of this work on GS. So we continue this iteration. We go in one school, and then we move on to more schools, a couple more schools. At some point, the Ministry of Education, they fund us for doing this research. At some point, they get excited, and then they help us to take this to 6 other schools. So it's not just solving practical problems in school. So we have to sit back and reflect. What's the essence of this pedagogy? Why it works the way you work? So we have some reflections, and we think that it's because it's simple and easy to use. Within the first half hour, students can start using it. And it's really face-to-face CSCR. It's not just online. I think Miguel will agree with me. We really need face-to-face collaboration, mediated by technology. And then we develop design principles. How can teachers design collaborative learning activities using this technology? I think I have 1 or 2 slides to talk a bit on this later. And we don't develop a new curriculum and expect students to, it's not outside the curriculum. It's based on the existing curriculum. And this is very important because schools will not care about, you teach them new things or 21st century skills. They worry about the bread and butter issue, how to teach the current curriculum. Co-design lessons with teachers, extensive professional development, and what we call enculturation effort. So when we get teachers to use this and students to use this, we don't straight away start with the technology. We start with the paper version, the sticky note version of it for a couple of weeks in order to get them enculturated to the practice. And it's routine use. So every week they use this. It's not like researchers go to the school and then do 2 weeks of intervention and then they come out of school. It's every week of the semester they use this technology. So it's routine use. So we have this metaphor, to help schools, classrooms, help teachers to adopt technology, integrate technology. It's not just developing the technology. It's not just developing the pedagogy. You must look at the other aspects of other aspects of the ecology. So you think of a barrel. I have this metaphor which I think Miguel likes it. Think of a barrel with all these different planks. And the capacity of the barrel is determined not by the tallest plank, but by the shortest plank. Think of you address all the other factors. If, for example, the classroom culture is not ready, the low plank, then the water will leak up from the barrel. So it's like your chain is only as strong as the weakest link. So you must address all these other issues. And this is where we believe that learning sciences approach can have a better handle to addressing these issues. You have to see whether the students are ready for it. Is there appropriate classroom culture? Can we work with the teachers' beliefs? Teachers' knowledge, teachers' empowerment. Is it easy to use? Okay, so we work with SRI and they help us to have some publicity of this work. So this is the National Educational Technology Plan 2011 from the Obama government. So we have a little mention of GroupScribbles. So the activity is in primary school science. Groups of students sketch different ways of forming electric circuit and share them by placing it on a whiteboard. So they learn by explaining the work to others and through providing and receiving feedback. Okay. So how the teachers design activities on using this technology? So we develop some principles, volunteerism. So activity might have different tasks, and we put the task in the public space, And let the students choose what task they want to do. So it's not assigned. It's not like you do this activity, you do that. So you put all the tasks, the subtasks into the public space, and the students can pick what they can do. So we call that volunteerism. So you can pick a problem that is that is suitable for you, that's something that you can manage, and then at least you try, you put in effort, rather than sit back and you say I can't do it. Spontaneous participation, activities that require multimodal expression. So it's not just text, it could be scribbling or could be something else. Higher order processing. So you have all these notes together, how to get the students to organize it, cluster into different categories. So that promotes higher order processing, synthesis of ideas. So you ask them to think of language learning, you put down a lot of words associated with the C. You ask students to organize this into nouns, verbs, adjectives. So the ideas are generated by the students, and then you get them to do this higher order processing. And the idea is, every idea is improvable. Kids think that knowledge is objectified. There's a correct answer to everything. But tell them that these are just ideas, and ideas can be improved. So it's an epistemology which many educators want students to walk away with. Science is not objectified knowledge. You have to know it. Science is also knowledge which can be improved through paradigms, through research, through change. So get them to develop a certain epistemology towards science. Science is not just accepted knowledge and facts. It's good to have diverse ideas and give students the agency. They have the agency to contribute. It's not just the teacher standing in front of class and telling them all this. It's democratized, and knowledge advancement in the class is symmetric because everyone has the same opportunities. So, yeah, this is basically explanation of what all these are. So, through a process of design-based research, we start with these principles. So, what we found is teachers, some of them understand this, but some of them find it a bit abstract. So, they need more help to operationalize these principles. So, this is the next phase of research. We try to create, to move beyond these more abstract principles. So, we try to simplify it so that teachers can understand it. Those principles, not every teacher can understand it. So we simplify it six principles which more understandable by teachers. So this is an iteration of design-based research. We researchers come up with very abstract principles, and we think teachers can understand it. But you go to a classroom, we know what they can handle, and then this iteration we try to make it easier for them. So we try to think of the principles in more concrete terms. And then we try to develop logic models or explaining how this works. So we work with Charlie Baton, SRI, trying to develop logic models of how this works. Why is this working? How do you have this learning efficacy? Okay. Then we develop, our notion of rapid collaborative knowledge improvement. So this is more the theoretical part. We've done the practice part. Now we reflect back and see, what can we contribute to the literature? And then we had this notion of rapid collaborative knowledge improvement. So rapid is done in a limited time of participation in an actual classroom lesson, and use a lightweight form of expression. Just scribble, lightweight, and the lightweight encourages discussion. So think of it, you are at a restaurant and you're telling your friends some ideas, then you take the napkin and scribble it. So exactly the same idea. To use the representation to generate discussion. So these are further work where we try to develop more scaffolding to help teachers to design lessons. So we have these visual scaffolds to help them to develop lessons. So I won't go to the details. So all these are, we have published a couple of papers and presented at conferences. So it's a line of work that leads to helping teachers to develop collaborative learning activities in different subjects. Okay, so maybe it's time to end this talk. We can talk the hour. So where are we? So I started off by talking more broadly about the learning sciences field and how is it different from other traditional disciplines, educational psychology, instructional design, educational technology. And so I thought about design-based research as a methodology, iterative, it's collaborative, and it's also has an intention of building on theories to develop or refine theories. And the sense is this approach gives you a better handle for doing things that can be adopted in schools. So we promote collaborative learning. So we also do a lot of collaborative work. So collaborate with researchers. That was before I know Miguel, so I collaborated. Jeremy Rochelle, Charles Peter, and Nathan Dwyer. And then a colleague from Taiwan. And then Ben Sutters from University of Hawaii. So this is my team. This earlier team, so some people have gone, but more people have joined us. And then I have another project on mobile learning. We use the notion of seamless learning. So you search the website, you'll see a couple of papers on this seamless learning. And we work with 2 Americans. And there's a guy from Croatia, so we work with him. So we are quite international in collaboration. So that's it. All right. So we have learning sciences folks. We also have the content people, the science education folks. And then we have software engineers. And then we have researchers who collect data in the form of, we have classroom videos. In fact, we collect more classroom videos than we can collect. So we have educational researchers who will do some coding of this classroom data. And then we have the quantitative results where you need people familiar with statistics to analyze them in terms of the learning gains. What else do we have? So we have people from experts in collaborative learning. Dan Sutters contribute towards the notion of uptake analysis. This is very micro level. How to trace the you uptake an idea. Somebody posts a note there. For the note, who builds on that note to generate new knowledge? So has been looking at it from the point of view of uptake analysis, and we use this approach to try to trace the development of these ideas on GroupScribbles, and also verbally. Jeremy Rochelle, I think there are earlier workshops that bring developers, researchers together to develop this GroupScribbles technology. I think it was in 2005. Miguel probably went to one of that. Yeah. So he provided the first version of technology and gave us some initial pointers, and we took it to Singapore classroom. Charles Payton, we worked with him on the logic model, so trying to unpack how to explain the effects of all this. Okay. I don't know whether I answered the question. What is a broad sense of that? Yeah, so this is social culture. Singapore is probably different from Chile. So we have it's a small country, so we have a very close nexus of relationship between the Ministry of Education, researchers, and the practitioners, so the schools. So I think we are aligned in the sense that schools want to innovate. So school principals encourage teachers to try out new pedagogies, and there's an incentive and a motivation to do this. And we help to, we help the Ministry of Education has certain policies in place. They want to promote collaborative learning, but they put it in very broad terms. So we come in to operationalize this and help schools to understand how to get started. So in that sense, there's this nexus and there's this alignment of goals, which make us really easier to approach schools and for schools to find teachers to get this going. So in general, because of this close nexus, we have the privilege to have schools that are ready to do all this innovation. So early on, we have mentioned all these research projects with schools. We were. I think there are more schools that want to do things differently than the team than what we can cope. We have a lab and we have a limited number of researchers. Sometimes schools have a think that they have a need, a pedagogical idea, and they come to us, and so you just can't cope. A project like this, takes a lot of years and a good team to continue this program of research. So that's Singapore context. And my institute is responsible for teacher training. So the outputs, some of the outcomes of this research, we feed back into the teacher education, so that some of the teachers are aware of these approaches, and when they go to schools, they can try out these approaches. So we look at this in more holistically to see how we can impact the system at different levels. Yeah.
For example, people designing a product or trying to expand this part or something, might interact in a similar way as
apply it differently to we apply it to learners, to students in school, and so the other project on seamless learning. I think we go a little beyond. We go to some of the homes of the students to understand what they do informally, what practices they learn informally. So it's something I haven't not really been working on. So maybe I hesitate to respond to the question. Working with a different type, group of users, products. But I think in terms of technology, if it's product development, technology development, I think the same approach is appropriate. I think think of it as a rapid prototyping. Those approaches, quick cycles. I think the software now there is quick cycles of software development. So I think this approach is very much aligned with that. You develop something quickly, test it out, and then you iteratively develop that prototype or product. Yeah. Questions, comments? Yeah. Yes, generally, but we have different schools. So some different schools, some use more ICT, some use it less. Every school has ICT provisions. So the sense is most of them use it in very general standard ways, like teachers use a lot of PowerPoint, and students may search for information, do projects on internet. So we have those more basic use of technology. So what we want to do is really think of ways to empower learning, think of the new learning environments where they can learn in deep ways. So I think it's one of the ways to, one of the charting what are the ways to bring about collaborative learning? Yeah. We do it, we do it continuously. So the first version of software comes from SRI, as I said, but it was kind of unstable, sometimes it just crashes in classroom. So the first few months was a bit, was very nervous, and we were glad to have teachers who know how to recover, how to work around. If technology fails, how you really put teacher on the spot, and they need to, do something. We are fortunate teachers, know how to recover. So based on those feedback, we redevelop the technology, using Flex, redevelop it and make it more stable. At the same time, add new functionalities. For example, more functionalities for teachers to have a sense of how the students or groups are performing, the notion of orchestration. It's somewhat finished now, it's somewhat stable now, and it's been used in schools. But to take it to the next step where many more schools will use it, we really need to prototype it. I think that needs a new team, and we haven't got to the stage yet. And that's the issues of translation and scaling comes in. We're learning a lot of things. We're only researchers, and in the end, we can't support the schools to periodic basis. We need someone to own the problem, or who can make a business out of it to continue to support the schools, at least from the technological support sense. And also need people to train the teachers to do it. So maybe, we had this idea of, someone who can make a business out of it to sustain. We have some of the standard apps on the mobile devices. These are smartphones, so apps for them to draw concept maps, to do simple animations. So this is another project. It's also another multi-year project with a large team of people. And we have elementary school science, the curriculum for 3rd grade. And so we work with the teachers to redevelop the curriculum so that can be delivered on these mobile devices. Yeah. I have a video on that. If you like, I can show that to you. The short video. So this is a different effort where every child is given a smartphone, and we hope that they can use it as a learning hub because it's small. You can put in a pocket, on the train, on the bus home, at home. They can continue the science learning activities. And the software apps are very simple, but we look at the curriculum and then try to think of ways they can do activities through the smartphone. And so we do it for the 3rd grade and the 4th grade. And results are good, and the principal decided that all the classes should do it. So that's the scaling. All the classes should do it. And the software becomes an issue because this runs on the Windows platform, and so not many smartphones use Windows, and the problems with it. So there's another team, they are redeveloping the software and trying to develop an Android platform. But from the pedagogical side, it's promising because the school decided to have it on more classes, and also to do it for English language and for Chinese language. Yeah. So it's not just a one-off effort. We think of it as research leading to more research, and so a lot of funding agencies do not realize this. They fund short-term research, and we continue to ask for more research grants and just working within a school to study this effect of school adoption. So we're still asking our Ministry of Education and National Research Foundation for more funding to study this scaling up in the school. Yeah. Yes.
The video was very nice. How culturally dependent is what you show? Would you say that what you've shown there could be applied in San Francisco, for example? That experience, could you extend it to San Francisco? Or to another place in the US?
Yeah, I don't really know that yet.
So the question is the context.
Yeah. It's a very good question. So we have, we work with the 2 Americans, Elliot Soloway from University of Michigan. Some of you may know him, and Kathy Norris from University of Texas. And they come often to Singapore. Every time they come to Singapore, they tell us that we never see that in US schools. So we don't know, different cultural contexts. Maybe we need research to do that. But my sense is, why not? I mean, these are really science activities. They have a smartphone, and some of the smart activities they're asked to continue doing at home and involve the parents in it. Some of it has a notion of flipped classroom, because classroom time is limited, so they're supposed to do science activities outside the classroom and then bring to class for the teacher to discuss. So I think while this is going on, I think so Elliot and Kathy might be also working out with some schools in US to try some of this.
They have done this in the US.
I think we lead the way first in a Singapore classroom. I think they're also interested to see, to have a broader user base, to create a model one-to-one. So that's why they're very much interested to make this work, and come to Singapore a couple of times, and Elliot uses students to develop the software. So it's, we can talk about that. Yes. Yeah. Yeah. I think it's still a very good role for experimental research. I can understand. You're in the computer science or engineering department. You a certain solution, a certain learning environment and technology in mind, and maybe that's what you doing an experimental approach can help you answer the kind of research questions you have. So that might be and be okay for your PhD research. So I think this notion is trying to address a broader issue. I think those are very good first steps, very good building on knowledge based on building these effective learning environments. So I think the message here is all these necessary ingredients, the planks of the barrel need to be put in place to address issues or impact to practice. So you need more people. You can continue to do the good work you're doing, but to really flip the school, I think we need another group of people. You may even need different disciplines, need people in organizational science to bring this to school. So I think that's the message. And the complementary approach. So I don't want to say that learning sciences is the best approach. And each discipline is very well established, and they have their own. They are doing very well in the kind of goals they have in the discipline. So here I address the problem of doing things that matter to school and making a real difference to schools. So all these considerations brings to bear in the classroom. So I have a lot of respect on educational technology research, the experiment testing, a lot of novel, new ideas and pedagogies. I think all those work needs to continue, to give us the ideas. We take all these ideas and try to, add the learning sciences perspective and bring it to classroom. Yeah. So that's my perspective. You have a question?
Last question. Thank you very much.
Thank you.